carbon-12 is stable, it's normal carbon. It remains in the same amount or same level. Well, carbon-14, it's radioactive. Over time, it decays away back into nitrogen. So if you have carbon-12 here and you have carbon-14 here, over time, carbon-14 halves itself.
Keeps
we call
going.
that half-life.
Half-life. Well,
Yes.
what do you mean? I've heard that term. I remember
Yes,
that in
that's
school.
right.
What's a half-life?
Well, half-life is the amount of time it takes for a certain element to decay, a radioactive element to decay by half. So in carbon-14, you're looking at 5,730 years as a half-life. So what that means is, imagine you have this amount. After 5,730 years, it halves itself.
Okay.
And another 5,730 years, it halves itself again. So you get a quarter.
A quarter left.
1/8, 1/16, and so on.
Well, eventually it would go down to almost nothing, right?
Yeah, eventually it will just be all gone.
Wait a minute here. So if indeed carbon-14 has this half-life of, 5,730 years is a long time, but compared to millions of years, it's not very much. I'm thinking that if it goes down to a half, and then after another 5,000 or so years, a quarter, 16th, an eighth, 16th, and it goes down. I mean, there's a certain point that there wouldn't be any measurable left. I mean, when does that happen?
Yeah, that's right. So it keeps halving itself, and we say that the upper limit's about 50,000 to 100,000 years.
Oh,
So in other words, if you have a fossil that is more than 100,000 years, it should not contain any carbon-14. All of that should have degraded away.
yeah. Don't they oftentimes tell us that these fossils are millions of years old?
Yes, that's what evolutionists claims.
So this is kind of a problem, isn't it?
It is, because the thing is, almost every fossil that we test contains traceable amounts of carbon-14.